Good morning and good afternoon. I am Xiaojun, a sword maker or sword smith of a Longquan swords. I'm going to this is the topic of my presentation, and I will basically cover 3 parts. The first one, the sword making in Han Dynasty. Number 2, the shaft furnace sword making in Jianzhong. And the third one is the reconstruction of the ancient styled sword. So for the interest of time, I'm going to focus more on the second and the third part because we have been working on it in the past 2 years. So therefore, I would like to share more details about what we have achieved in the past 2 years. Now, let's look at the shaft furnace in the ancient style. In the ancient time, as you know, that iron smelting technology and output actually marks how developed a nation's society was in terms of material civilization. There were 2 types of, or 2 schoolings of iron making. One was from West Asia. It's a block smelting steel infiltration technology. This technology came from the West and it was popular in the society. The second one is based on the pig iron steel making technology. So it was a local technology. Both technologies were popular in China and they were used differently for different purposes. Recent researches show that in the 6th century BC in China, people began to use shaft furnace to make steel and make iron. And later, pig iron and pig mine-based steel technology also came into existence. So these 2 systems served well in mainland China in the iron making and the steel making. And also they provided good materials for the downstream business sector, for example, for the agriculture sector, for the military sector, the transportation sector, so on and so forth. And they were a very important driver in the ancient civilization in China. They served very well as a bridge in the heritage of the ancient Chinese civilization. It was regarded one of the most important technologies invented by the ancient China. It had over 200 or 500 years of history as an intangible culture, and being a very important part of sword making in Longquan shaft furnace technology is now on the verge of being lost with no successor. Now I am an inheritor of such ancient technology, and we set up the Longquan. We set up a Longquan Academy or Institute to study into the shaft furnace, the forging technologies of sword making in order to remake the swords as our ancestors did. And I think this is a very important responsibility for any inheritor of our ancient civilization. It is also where my passion goes to. In spring of 2019, we worked together with the Institute of Metallurgy and Material History, University of Science and Technology, Beijing. Meanwhile, we received great support from Professor Huang Xin from Institute of National History, Chinese Academy of Sciences. In Longquan, the sword village, we began to rebuild the ancient furnace as well as the remaking of ancient swords. So this has been a very successful cooperation between a civil cooperation as well as the academias. We took reference of the ancient technologies for example, in rebuilding the furnace. We chose the quartz ice and clay and quartz sand, carbon powders, and so on and so forth in order to build the furnace body. We also prepared charcoals that were specifically fit for iron making. We collected iron sands as required in the iron smelting in the ancient times. Meanwhile, we also designed different steps of the iron making And meanwhile, we used a lot of new technologies such as the thermocoupling, the infrared tester, the infrared thermal imager, the hot air anemometers, air pressure transmitters, paperless recorders, handheld XRF, so on and so forth, in order to monitor and collect data during the iron smelting. After the smelting, we also conducted dissection of the furnace. We analyzed and recorded the data. We also further analyzed the data to generate a report. So this is the first step. So meanwhile, we also try to restore all the ancient technologies. And meanwhile, we also selected the raw materials series carefully. In this project, so we conducted the project step by step. The first, we had to design the furnace. By designing the first furnace, we took reference of the old furnaces in the ancient time that were discovered during the archaeological activities, particularly the furnaces during the Warring States period. So this is what a furnace looked like. We also went to Oujiang, which is a local river in Longquan. We collected the iron sand. It's a sulfur-free sand, and about 50% of iron content, very high grade. So this is the picture. We use a magnetite to get the iron sands out of all the sand. Meanwhile, we also prepared charcoal. We call it white charcoal because this charcoal contains very high energy and can reach very high temperature for iron smelting. And step 4, we collected quartzites and limestone for the sake of building the furnace. We also use the clay in the building of a furnace. So because we have a rich reserve of quartzites, it can endure very high temperature, as high as 1,800 centigrade. So that can support for iron smelting. If you use pebbles or bluestone, the stone may crack. So quartzites is very, very important. Quartzites for furnace building. This is building the furnace. This is smashing the stone. This is the hearth or the furnace base. This is critical. If the furnace or if the hearth is not very well prepared, then the molten iron will go deep through it to the ground, to the soil. This furnace, we use the stones, and while we build it, because a lot of stones, they are round, just like a cobblestone, and some are rough stones. So that's why it's not easy to build a furnace. After building the stone, after we're building the furnace, we have to season it dry with fire so that it can reserve the temperature inside and keep warm. So see, this furnace is well built. At that time, we didn't have a lot of experience. And when it was almost finished, it just collapsed. So later we tried again and we tied it with wire. So during the burning, during the smelting, the furnace will keep strong. And this is our first experiment. This is the second furnace. So these two furnaces were both used for smelting. So this is the first furnace. So working now, the flame is very, very high. And step 5, we start the melting process. At that time, so we put one layer of charcoal, another layer of iron sand, and then another layer of charcoal, followed by iron sand. The whole furnace cavity is filled with charcoal and iron sand. After that, after the ignition, the charcoal became red and got molten, and then the smelting began. We used the air supply system to blow into the fire so that the flame became higher and higher, from small flames to very, very big, very high flame. We added charcoal into it, and the flame can be as high as 10 meters high. It's fantabulous. It's fantastic. So it's a very beautiful picture. You can see here. So this is the smelting process. We added charcoal into it, and the flame just went up quickly. You know, there are pieces of bits of charcoal, and the flame just went up, and the charcoal, the bits just like fireworks. This is how we got the iron out of the furnace, because there's pressure in the furnace. That's why the iron, the melted iron would squirt out. It's a very strong squirt. After 5 hours of burning, this is how the iron, the molten iron came out. So the molten iron began to flow because there was only one hole, as in the ancient time. This hole is for the melted iron to flow out, as well as for the slave hole. We also use a limestone. The purpose of limestone is just like catalyst, so that the iron can be melted better. During the smelting period, limestone can also help with the separation of iron versus slag. So when we got the melted iron out, the slag would keep into the furnace without flowing first. We opened the hole, and the melted iron would flow out first. And after that, the slag would flow out. You can see here, the darkened area, these are the slags. Step 6 is data analytics. We prepared a report after that, and I wouldn't elaborate too much on the report. We used the thermocouples and different types of technologies and instruments in the furnace. For example, the thermocoupling, the imager, infrared imager, so on and so forth for data collection. In step 6, we also conducted dissection of the furnace to study how temperature changed in the furnace. We observed the process, how iron sand got oxidated and reduced. See, this is a dissection of the furnace. The upper side and the downside, the temperatures were different in the furnace. So therefore, you can see different signs of a burning in the furnace. At the upper side, the temperature was not that high, and the reduction didn't begin until very late. So you can see you can still see some charcoal and iron sand in the furnace. And at the bottom, the temperature was much higher, and the iron sand began to melt, and then the reduction began. After that, the melted iron flowed to the bottom to the hearth. You know, the hearth, there's a curve, just like a basin. And at the hearth, there you can see all the melted iron were gathered there, as this picture shows. This is the iron we got. There's another picture. In this picture, you can see it very clearly. Iron, the melted iron here, flown to the hearth. It's a very dynamic. And this is the solidification of molten iron at the hearth. Yeah, through the charcoal, through the furnace. And after dissection, we found that which point the temperature was the highest. Because of extreme high temperature, the clay was burned into gray in color, and the quartzite also changed its color because of the high temperature. The gray areas here If the gray area is very thick, this means the temperature used to be very high in the furnace. Step 6 is about the steel pouring of the pig iron. We used both pig iron and the wrought iron together, and we used the compound technology to forge together. You can see this is our furnace for forging. This is not a very big furnace. See, the temperature went up and the forging began. Because that in the pig iron, there were a lot of impurities. That's why you can see there are a lot of sparks while forging and folding. So this is a picture during the pouring period. So it's wrapped, the pig iron and the wrought iron, they went together and melt together, and this is the forging process. This is the forging, as well as the ingredient adding period. So based on this, we burn it and put it together, folding, forging, stretching, so on and so forth, and repeatedly. So it needs over 330,000 times of a folding, forging. And this is a rough piece of a forged iron. And if it is stretched, it can be served as a rough piece of a hand sword. And step 8 is about summary. Now, let me share with you more about this summary. The forging and the sword remaking following the ancient shaft furnace. We rebuilt the furnace. We used the local materials in the furnace building, the quartzites and the charcoal and limestone, so on and so forth. We spent half a month to rebuild the furnace. We used about 15 tons of quartzites. We built up 2 furnaces for the sake of 3.6 tons of charcoals for the iron smelting. We also collected over 3 tons of iron sand from the Ojiang. Meanwhile, we used 5 thermal couplings, 1 infrared tester, 1 infrared imager, 1 air blower, and 1 pressure transmitter, as well as 1 paperless recorder and 1 handheld XRF device, that is an analyzer for data collection and data analysis. In this project, we dried the furnace for 3 times because you had to dry up the furnace to get rid of the humidity. Every time, every drying up process needs about 20 hours. Every time it needs 20 hours. For each drying up, we need about 500 kilograms of charcoal, and it takes 2 weeks. And warming up of the furnace takes about 30 hours. The first adding ingredients to the last minute, the melted iron flow out. The whole process is about 5 hours, 1 ton of charcoal, 500 kilograms of iron sands, with generating 150 kilograms of pig iron. This is a huge project. So one step by another, followed by another. The pig iron we got was used for the raw material for the reproduction of a hand sword. Now let me show you how this sword was made. Let me show you the pictures first. So this is the forging of the blade. So after getting the rough sword, the raw material, we used forging. We began the forging process for the blade. So we need to forge it repeatedly, again, and again. So you burn the pig iron to red, you stretch it, you forge it, and you fold it and forge it again. In this process, you can see a lot of sparks, which are actually the impurities. So the repeated folding and folding about 30,000 times. It takes about 15 days for the forging and repeating. and folding. So this sword is from a Han dynasty, very well preserved, very well kept. So we are going to remake another Han sword exactly like this. This is the 1:1 scale. The length, the width, the weight, because this sword is very well kept. Even the cutting edge, the overall body, very beautiful, very well kept. And the ring was very carefully made and looks very beautiful. So based on this sword, we're going to remake it. This sword is also from Han, very well preserved as well. You can see there's some paint from the scabbard, including the carbonized wood hilt and the guard. They're very well kept. This is another one, also a ring-pommel sword. The guard is still here. So meanwhile, we also studied their swords in the Han dynasty. And also this one. This is another sword. We have other collections as well. So based on this Han dynasty, we're going to remake a new sword exactly like it. After the remaking, we cover it with soil and burn it again. So cover it with soil and burn it again. Let me explain a little bit. So if you have ever noticed that the Japanese sword, there's a curve. So that is actually a result of a crunching and hardening. And the techniques in Japanese sword making is from China. This is the burning. Because after, for the heat treatment process, the temperature is very high, the furnace is much longer. And this picture is from another angle. And this is the sink. See, the red iron was put into the sink. And then after that, we covered it with soil and burn it again. And after that, we will adjust its shape. After the heat treatment, usually the shape of the blade may become D-shaped. That's why we had to adjust the shape. So we were going to remake a same Han sword. So after the shape was done, we began to sharpen the blade. So this is the blade. And finally, we add the ring to it. And finally, it is done. This is the finished one. Let me show you the sword we made. So just a minute. This one. This is the finished piece. You can have a look. The shape is exactly the same. The length is the same. The shape is the same. The width, the thickness is also the same. You can also see that in the details, particularly the sword head is slightly upward. It's very beautiful. So the curve, the line, very beautiful, because it is made by folding and forging. So you can see all the forged patterns on the body of the blade. And maybe you can't find them you can't see the patterns very clearly in this video. I'm not sure whether you can see them, all the forced patterns. Perhaps it's hard for you to see them clearly because it is very well sharpened, and because of the light, perhaps you can't see them very clearly. But if I show you on site, you will see them very clearly, all the forced patterns. Okay, so for the remaking of the Ring-pommel sword, it took us about 2 years to make it. From the building the furnace, washing the iron sand, and forging and finishing. The whole process took us about 18 months. For the remaking process, took us 24 months. So a lot of difficulties, however, a lot of joy as well. And this is something that you can only experience them by yourself, cannot describe them with words. However, whenever I got tired, when I got upset, think about the significance of making such a sword. I just felt that I was powered up and I could keep doing on it. So whenever I look at the details, I always felt impressed and shocked by the handicraft of the swordsmithmen in the past, tens of thousands of smithmen so many years ago. So I think that for the sake of the rejuvenization of a Chinese sword culture, the remaking of the hand sword is an example of we smithmen or sword makers to undertake our responsibilities. This is also a way that we can rejuvenate our culture. Recently, you may have noticed that more and more people show the interest in Chinese swords and their sword culture. However, because of the lack of research on our sword culture in our ancient times, as well as the martial art popular literatures, there are a lot of remaking by people without careful studies and research on the true history of such swords. This will hinder the juvenilization of our sword culture in China. This will also distort people's correct understanding on Chinese swords and swords culture. I believe the juvenilization must start by restoring our ancient techniques before we begin to remake the swords. So based on this, we can begin our innovation. The remaking of this hand and sword is my personal effort. Understand that it is not perfect yet. However, for each mistake will become a driver for me to keep working on it and keep improving. I hope that through my own slight contribution, I hope that we can realize rejuvenization of our sword culture in the future. Thank you.